It's important to make the distinction between population sampling and group assignment. Population sampling refers to the selection of participants from the entire population of interest, whereas group assignment refers to once you have that sample population, how you assign them to a group, either the treatment group or the control group. When sampling the population, the first thing you have to be concerned with is your unit of analysis or the experimental unit. That's the entity that you'll be analyzing in your study. If you're not sure what that is, you just have to ask yourself, what are you making measurements on? If you're collecting data on individual students, then your unit of analysis is the student. If you're collecting class-wide data, then your unit of analysis is the class. Below, I've listed the most common ways to either random sample a population or randomly assign to a group. Simple random sampling is when every member of the population has an equal chance of being selected for your study. Stratified random sampling, sometimes called proportional sampling, involves dividing your population into homogeneous subgroups and then taking a simple random sample in each subgroup. There are several reasons why you might prefer stratified sampling over simple random sampling. One thing, it assures that you'll be able to represent not only the overall population, but also key subgroups in the population, such as IEP students. So for example, if you know that the larger population has 10% IEP students, you might want to make sure that you have 10% IEP students in your sample population. Cluster random sampling is when the researcher divides the population into groups that we call clusters, like a classroom, for example. Then you do a simple random selection of those groups, and every element or every student in that group is sampled. Complete random assignment means, now remember, now we have our sample population, and now we're going to assign it to a group. To do a complete random assignment, it would mean like flipping a coin for each participant and randomly assigning them to either the treatment group or the control group. This means that it's possible that your groups may be of unequal size, which is not always bad, but if you want your groups to be of equal size, then you might consider doing what we call a permuted random assignment. That would ensure that each group, the treatment group and the control group, has an equal number of participants. Random block assignment is analogous to stratified random sampling, and that it ensures that you are assigning so many of each group or each strata to either the treatment group or the control group. So let me show you the most common ways to do that with Excel. So let's say I have a sample population here from A through T of 20 students, and I want to randomly assign them to either the control group or the treatment group. So I've let 1 equal the treatment group and 2 equal the control group. So I'm going to go and select this cell, and I'm going to hit equals rand between. So you want the rand between, and then we're going to say 1 comma 2. So that's picking a random integer between 1 and 2. And so in this case it picked 1. Then you're going to grab that cell and pull it all the way down. Excuse me. I'm going to grab that cell and pull it all the way down. And it randomly assigned a 1 or a 2 to each member of the sample population. Now I'm not going to count these, but it's possible that I have an unequal number of 1s and 2s. Permuted random sampling, remember that's when we want to assure that we have equal number in each group, is when I'm going to go ahead and I list out my population, and I've made half of them I have assigned treatment, half of them I'm going to assign control. But now I want to scramble these lists to make it random. So now I go over here and I just type equals rand, open and close parenthesis, and it picks a random number between 0 and 1. You're going to grab that cell and fill all the way down your columns, and it randomly assigns all those a random number between 0 and 1. I'm going to click on there. I'm going to go to my data tab, and I'm going to sort this list, either A to Z or Z to A. I'll just pick the bottom one, and notice how it scrambled the list. Each column got scrambled. So now we've randomly assigned that sample population to either the treatment group or the control group, and we have an equal number in each one. So let's take a look at our worksheet again. So here I'm going to identify the group, my unit of analysis. Now, I could have done this with all my students in all my math classes, but I went ahead and narrowed it down just to Algebra 1A students because I believe that's where students seem to struggle the most. And then I'm going to define my treatment group and my control group and how I sampled them from the larger population. So in this case, is what I'm thinking of doing with this study is every single time I'm assigned an Algebra 1A class, I flip a coin and I assign it to either the treatment group or the control group based on it's a head or a tail. And then the next Algebra 1A class I get, I assign it the other one. So if I flipped ahead and I assigned one Algebra 1A class to the treatment group, then the next Algebra 1A class I got would be assigned to the control group. And I'd keep repeating this process. I'm doing it this way because I have no idea how many Algebra 1A classes I'm going to be assigned over the course of a semester. So now I've selected my unit of analysis. I've decided that every Algebra 1A class is either going to get a treatment or control, and I'm going to randomly assign those. Now I have to identify my variables. The treatment variable is generally just a treatment versus no treatment. In my case, the intervention I'm going to do with them. So I'm going to give them modified instruction based on formative assessments, or I'm not. So it's either intervention or no intervention. My response variables are how I'm going to measure the outcome. So in this case, I want to define how I'm going to improve student learning outcomes. What are those learning outcomes? So I went ahead and selected exam scores, project scores, maybe final grades, maybe surveys. Maybe I won't use all of these in the end. It's important to list out as many as you can, even qualitative and quantitative both. So go ahead now and select what you want to do